Okay, let's start with why educational robotics. Probably we are all aware that educational robotics has become increasingly integrated into kindergarten, primary, and secondary schools across the US and many other countries in recent years. Researchers have found a spectrum of benefits for incorporating robotics into existing school curriculum. I know a lot of you are school teachers. Probably you have already integrated robotics into your curriculum, or you're planning to do so. Why do we want to integrate robotics, and why we want to teach and learn about education robotics? First of all, we want students to be able to understand the world they live in. Nowadays, robotics are prevalent in our daily lives, and that prevalence is increasing. Students see them at home, on the way to school, and in the schools as well. Learning about robotics and help students understand the world they live in. Similar to understanding our world they live in, we also, as teachers, educators, we also want to prepare students for their future job skills. It's a necessary job skills for them to understand about robotics, engineering, STEM knowledge. The other thing about current skills and also future skills is about developing computational thinking. Educational robotics can be an effective tool to teach computational thinking. Students can program their robot to perform complex tasks, both in the classroom and on competition fields. For example, when students learning about sequencing, being able to program a robot to do certain behaviors, teaching about loop, teaching conditional statement with sensors on the robot, all of those are considered as computational thinking. The other thing students are able to learn through robotics is will be able to become comfortable with iterations and value the importance of learning from failure. Through disassembling and assembling their robots or debugging their programming, when they program their robot, they can definitely understand the importance of learning from failure, and they will be, comfortable with iteration, build it again and again and do the same coding. They need to identify the coding and modify that and to do debug. Last but not least, the most important thing for learning about education robotics is actually robotics can help integrate STEM education in novel ways. Education robotics is the best organizer for integrated STEM teaching and learning, according to research. For example, they will be learning about math when they learn about, the different angles of arms and the gear ratios. And when they build their robot, it's definitely the learning about engineer. They will also be learning about science, math. All those are integrated in the robotics learning journey. Just a little bit about us, VEX Robotics. We are an educational robotics developers of hardware, software, and curriculum that is used in classrooms around the world. We are wholly owned by Innovation First International, and we have different offices in the world. For Hong Kong, we support educators and partners in APAC region. And just also wanted to mention that and share with you, the VEX family of competition is the largest and fastest growing robotics event globally. Currently, there are more than 27,000 teams from all over, from over 60 countries competing worldwide. At VEX, we feel that the use of robotics and computer science in STEM education is a great driver to help students become creators using technology, but not just consumers of technology. So from kindergarten all the way to career level, we have STEM solutions for all ages. Our robotics platform, as probably you can see from here, have a very low barrier to entry and a very high ceiling. Teachers and students, they can get started as novices and as young as 4 years old when they're in kindergartens, and then they can potentially progress to career. So all the way from kindergarten to career level adults. Today, we would like to focus on VEX GO, the second of our full continuum for students ages 8+. So without further ado, let's dive into the focus today, VEX GO. For our VEX GO platform, it is an affordable construction system for students ages 8 to 12 that teaches the fundamentals of STEM through fun, hands-on activities that help primary students perceive coding and engineering in a fun and positive way. Why we call it construction system? Probably as you can see from the image on the PowerPoint, students will need to build their robots using different kind of tools, robotics parts, plastic parts, sensors, batteries. They will need to build them, construct their robot, and then power it and code it. Those are the 3 broad steps we recommend for teaching STEM using VEX GO. Really wanted to be able to help educators, to help you to teach STEM to students in a scaffolded way, in a progression. Build it first and then power it and then code it. We will be sharing more examples with you in later slides to let you know more about like what kind of examples, teaching examples of those. Before I talk about the teaching ideas or how to implement that into your classroom, just wanted to let you know there are 2 ways to go, like 2 different kind of kits you can buy. The first one, what we call is Go Education Kit. One kit is for 2 students. Usually, of course, if each student they want to own their own kit, it's definitely possible. That is the Go Education Kit. For 1 kit, we've got organized parts, organized storage bins, electronics, motors, and sensors. And it enables students to do unlimited builds with the VEX GO Education Kit. For classroom, usually we would recommend teachers to use classroom bundles in a classroom setting. The classroom bundles are for students, like 5 students, 10 students, or 15 students in a class. It includes 5, 10, or 15 Go Education Kits. It includes, it has like organized storage and carrying cases on top of the storage case. And it also includes the robot fields. Probably you can see here, and walls, probably the robotics field and walls, and also parts, posters. You will be able to do different kind of STEM activities with students using those robotics field and game elements. And there are spare parts provided to you for the classroom bundles. And also the chargers, for example, chargers for 5 batteries. You can charge 5 batteries at the same time. That would be easier for classroom management. In the classroom bundle, you would also be able to find this, as I mentioned, the fields and field tile and walls. It includes those field tiles and walls that can be snapped together to create a consistent space on which to test the VEX GO robots and VEXcode Go projects. Those field tiles can be arranged and rearranged to create a variety of different robot playgrounds. You're thinking about how you will organize your classroom space to go with your students.
Ang ending, ang last na dyan niya kay competitions.
Oh, all right. It would be great if you could mute your mic. Yeah, thanks. If you have any questions, you can type them in the chat box, or we can address your questions in the Q&A session. We just talked about the field tiles and walls enables you to do different kind of classroom activities with students. Just some ideas to share with you. For example, you can compile your field tiles into like zigzag turns, or you can change it to racetrack or U-turn. Different possibilities are available on our STEM lab. Open resources, free resources for educators. We'll be able to share with you in later slides. What we've also got in terms of hardware, we've also got this VEX GO Competition Field Kit. The VEX GO Competition Kit contains everything you need to build one of 4 different themed games with your VEX GO Competition kits. We have 4 themes for our VEX GO competition. We've got Mars Math Expedition, Ocean Science Exploration, City Technology Rebuild, Village Engineering Construction. It allows task-based learning and project-based learning. My colleague Flora will be sharing with you more about this VEX GO competition. It allows you to do classroom level, school level, or community level competitions. Talking about the VEX GO kits, one of the features which makes the VEX GO such an easy building system is the parts have their own unique color, as you can see from the kits poster here. These colors help match the parts to the steps in the build instructions. The build instructions are the step-by-step instructions for students to build their robot. Color-coded parts are also very easy for classroom management. As you can see from this poster, like for example, the yellow beams are always smaller than blue beams. When you ask students to identify different parts, you can ask them to identify, the colors. And you can see, probably can see an example is the red beams are the smallest. The red ones are always the smallest in each category. That's really easy for students and also for the classroom management for teachers. How you can teach STEM with VEX GO with our platform. We recommend 3 steps for you. The first step is build it, and then power it, and then code it. We really want to provide you with the scaffolded skills and scaffolded methods to help students progress. I'll give you some examples about build it. Let's start it with this. The example I showed you here is called VEX GO Unpowered Supercar. Students can build the unpowered supercar and then measure and record distances the unpowered supercar travels in different scenarios. They can measure that and test that. They will be learning about how to predict an object's continued motion, change in motion, or stability. This is definitely the physics concept. They can learn about scientific thinking skills through this build. As a progression, adding in another scenario for this unpowered supercar, we can provide this ramp, ask students to test, predict, and measure the distance traveled of the supercar on ramp. And this is another example I wanted to share with you. With one build, you can do different kind of scientific experiments. Another example about build it. Is this robot arm. Of course, this is just one of many builds students can do with VEX GO. Students can build a manually operated robot arm to explore what a robotic arm is and how it works. They will be learning about engineering, about robot arms, and learn the math. For example, learn about the math behind the arms angles. Apologies, I'll have to mute you. Okay, thanks. Yeah. And they can also identify the movements of the robot arm and its limitations. So this is definitely an integration of STEM teaching and learning. Wanted to share with you more examples of VEX GO builds. All those examples, you'll be able to find them on our STEM lab. Education.vex.com. Those are our free educator resources for educators. We've got this free STEM labs and step-by-step students-friendly build instructions to help guide students through a variety of builds, such as vehicles, robotics arm, and so much more. Examples here on this slide are simple machines. We can teach simple machines to students. For example, this inclined plane, also known as a ramp, that can be set at 3 different angles to explore friction and force. Another example is this on the right, the scale lever to explore how a lever operates as a simple machine. This is just some of the examples. There are some, I saw some questions in the chat box. If my colleague Flora, if you could help type in the link I shared with everyone, like the STEM lab, it would be perfect. Otherwise, I will also be sharing the links with you, when I'm done with my parts. Don't worry, we will definitely share all the links, and also we will be sending you an email summarizing all the links, all the resources we've got to you. Thanks for your question. And another example category I wanted to share with you is about how to teach science using VEX GO. You can see some of the examples here, like magnet car. We can help students to explore magnetic polarity using this magnet car build. We provided step-by-step instructions for that. Or another example is this pendulum that attached to a VEX GO tile to explore gravity, pivot points, and frequency and movements. There are many more students can go. Some examples about VEX GO build here is about teaching math using VEX GO. For example, we can ask students to build this clock, and they will be able to explore how gears work together to transfer energy and affect movement. Also, they can be learning about fractions. They can use the handy tool to illustrate equivalent fractions and compare fractions by size. Those are just some of the examples I want to share with you how to teach math. Of course, there are more you can do. You can also use VEX GO to teach arts as well. We provided all kinds of activity ideas for you. The other example I wanted to share with you is this supercar. I've shared with you some examples about the Unpowered supercar and then supercar. This actual unit here, what I wanted to emphasize is the progression, the scaffolding way of teaching and learning. Students will be learning about the Unpowered supercar, and then on top of that, they will be adding batteries and switch to it. They will be learning about force, and then at the end, they can be learning about how to code their supercar. So this is an example of progression. For each unit, the progression is there, the scaffolding is there for you. This is just one example of the VEX GO build instructions. In the build instructions, they are students-facing instructions. Build instruction, they include a parts inventory, so students can gather all materials needed at the start of the building process. And we've got step-by-step visual images to show exactly how to orient and manipulate these pieces. For example, you can see it here. We've got before and after images. It's pretty visual, helps students to navigate. We've also got some of the symbols here. For example, you can see there's an eye there. It means we want students to pay attention to that parts, the direction of the parts, whether it should be on the front or turn it around the other side. It's really user-friendly build instructions for those small minds and their those like little minds and little hands. We've also provided you with different kinds of worksheets and routine checklist for you, criteria, rubrics for you. For the building parts, usually we would suggest students to work in groups. Some of them would be build different steps, and the other students, they can be journalists, which means they got other duties to do, like gather materials, write, do some experiment, do the testing, record their data. So students with different abilities and learning skills, they can be grouped into different groups to do different responsibilities. That's the first step I wanted to share with you, build it. The second step is power it. What does it mean by power it? It means we can add this switch and motor. We provided you with 2 switches in each kit. We'll be connect the switch with the motor and with the battery. And students can learn about force and what causes force. and they will be thinking about, can it be changed, the force? Students will explore how using battery and gears affects the speed of the car, and how does the motor and gears like affect the speed. This is means like power it, an example for the supercar. You don't need to use the like the coding app to code your robots to enable it to move at this step. Another example of power it is this robot arm. As you can see, we've connected 2 switches with the battery, and one switch control the base of the arm, and the other switch to control the arm of the robotics arm. This is just another examples how you can power your robot. Those are the first 2 steps: build it, power it. And the last step of teaching STEM using VEX GO is code it. I will pass it to my colleague Flora, and she will be able to walk you through how to teach STEM with VEX GO.
Okay, thank you, Kelsey. And I'm sharing my PowerPoint. Please wait a moment. So now you can see my PowerPoint, right?
Yes.
Okay, great. Let me adjust this. Okay. Hello, everyone, and I'm the robotics training teacher from VEX Academy, and I'm gonna share the code part with you today. And if you are new to teaching coding, block-based VEXcode Go helps you to get started right away. Here are 2 models commonly used for programming. The first one, supercar, and the second one, the code base. To set up VEXcode Go, you can either install VEXcode Go app or access VEXcode Go on the web for your device. The supported devices include iPad, Android tablet, Amazon Fire tablet, Chromebook, Windows, and Mac. Yes, and here are the VEXcode block features. First one, drag, drop, and drive. Students and teachers will feel instantly at home with this familiar environment. They can add or delete a block by dragging and dropping it. The second one is video tutorials. Building tutorials cover every aspect needed to quick get up to speed. And help is always there. Getting information on blocks is fast and easy. You can choose the block that you want to know more and then click the question mark on the top right. These resources were written by educators in a form that both teachers and students will grasp quickly. Next one, set up VEX Robot. We have 3 default settings in VEXcode Go, and we also have more than 20 example projects to choose from. These are the blog tutorials, and more tutorials are coming. And these are example projects. We have different types like motion, drivetrain, magnet, looks. Yeah. And after talking about the software, let's look at the hardware. In VEX Go, we have 3 sensors: LED bumper, eye sensor, and electromagnet. Let's take a look at the LED bumper sensor first. The VEX Go LED bumper is used to detect physical contact and display colors. When the LED bumper is pressed, it can be used to trigger a behavior. Here is a practical example. When the bumper is pressed, the drivetrain will drive forward for 150 millimeters. Okay, and the colors the LED bumper can display are off, green, and red. The set bumper color block is used to set the LED bumper to a certain color. Yeah. This. Okay, and next one is the eye sensor. The VEX Go eye sensor is used to detect if an object is near, and if so, determine the color of that object. Let's take a look at this example. The code base will drive until the eye sensor detects red. Then the code base will stop. Yes. The last one is electromagnet. The electromagnet is used to have your robot be able to pick up and drop disks. In this video, we use both electromagnet and eye sensor. Okay, and here is another example. Teacher can use robot arm to teach industrial robotics. Students can combine several robot arms together to transport the disks. And this is a great opportunity for students to learn about collaboration. Okay. Then I want to introduce you an app for teachers, VEX Classroom. The VEX Classroom app is a useful tool that allows you to get started teaching with Go quickly and easily. It is available on the following platforms: Apple App Store, Google Play Store, Amazon App Store. And the app can be used to easily update Go brain firmware, including updating multiple robot brains at one time. You can also use it to rename Go brains, monitor battery life, and monitor sensor data in real time. Okay, now let's move to how to integrate STEM labs into your curriculum. The VEX GO platform contains educational resources to support incorporation of meaningful learning experience into your existing curriculum. There are three main resources: STEM labs, activity series, and activities that can be used in conjunction with one another or as individual engagements. Let's take a look at the VEX STEM Lab teacher portal. Here you can find the teacher resources, pacing guide, activities, and all the STEM lab units. And in the teacher resources, you can find STEM lab materials list, all the build instructions, content standards, and much more. Okay, first let's talk about the pacing guide. The VEX GO cumulative pacing guide contains all of our STEM labs, activities, and activity series in one place that you can use to plan instructional sequences that meet your goals. And another one is the one-to-one pacing guide. This one-to-one pacing guide is intended to offer a possible organization for a hybrid robotics class using VEX GO and VEXcode VR in parallel. And it was developed as a part of the COVID resources to support teachers. In this one-to-one pacing guide, VEX GO STEM Lab units and VEX GO activity series are paired with single VEX GO activities that cover similar subjects or builds. STEM labs that cover computer science concepts are also paired with VEXcode VR activities that have overall computer science concepts in common. And all our STEM labs and activities are standard aligned and backed by research. You can refer to the website standards.vex.com to know the content standard and where and how the standards are reached. Here is the VEX GO STEM Labs. VEX GO STEM Labs are complete curricular units that can be integrated into your existing curriculum or utilized in a sequential order to provide comprehensive, integrated STEM learning throughout the school year. We have 24 units in total, and each unit contains 1 to 5 labs. The STEM lab unit can be categorized into 5 subject areas: coding, engineering, math, science, and competition. You can either filter the units by level or subjects. Here is an example. There are 5 labs in unit physical science. It follows the sequence of build it, power it, and code it. As we can see on this picture, here is an entry to the unit overview. For each unit, we have a unit overview. The overview provides a wealth of resources for teachers. They function as an online teacher's manual, and it includes step-by-step instructions, materials, lists, and letter home to engage and inform parents, and unit choice boards to give students voice and choice in their learning. Differentiation strategies, unit vocabulary, pacing guides, connections to standards, and easy to follow build instructions, printables to help students build, plan, iterate, and collaborate. It is very helpful for teachers to go through the unit overview before the class. Okay, and every STEM lab has a common structure that should make it easy to find what you need. We have engage, play, and share. An individual STEM lab might take about 40 minutes in one classroom, while another classroom will choose to complete it over several days. Students may be excited to extend their learning with specific STEM labs depending on their background, with the material and their personal interests. If you want to extend a STEM lab further, you can always choose to do the activities from the choice board with your class. And it would take teachers about 10 to 15 minutes to prepare for a STEM lab. Teachers can just follow the steps to prepare the class. Okay, let's move to activities. Go activities are simple one-page exercises that connect to the content and coding students are learning. They lend themselves well to independent student use, such as a learning center or morning warm-ups. We have 66 activity lessons in total, and they can be categorized into 5 subject areas: STEAM, science, technology, engineering, arts, and math. Here are examples of activities. Every activity is a one-page Google Doc. It will show you a simple name with a brief hook for students to know what the activity is about, and step-by-step instruction with supporting images for students to follow, and level up section that offers scaffolding extension ideas, pro tips that highlight VEX GO building or curriculum related to tips and tricks. And at the bottom is the aligned standards. Each activity is aligned to a standard. And you can download the Google Doc and edit it according to your classroom environment. Okay, and the last one is activity series. We have 6 activity series units. Go Activity Series offers a sequence of VEX GO activities with supporting teacher notes to create a facilitated lesson with your VEX GO kit. As you are looking for ways to incorporate VEX GO into your curriculum, consider the level of facilitation and scaffolding that you and your students need in order to be successful. All VEX GO resources can be used flexibly and adapted to suit your teaching style, comfort level, wisdom, and coding concepts, and your students' needs. However, each offering has a different level of teacher environment embedded into it, as you can see in this picture. Yeah. Next, I want to introduce you the VEX GO competition. The VEX GO competition brings the excitement of robotics competitions to your classroom and community. It is designed to be played within a classroom or in a gym or auditorium. The competition is also great for after-school activities and summer camps. This competition has 4 different themed mission and game fields. We have Mars Math Expedition, Ocean Science Exploration, Village Engineering Construction, and City Technology Rebuild. And we have 4 STEM lab units that based on these 4 things. Okay, then I'm gonna navigate you through other available teacher resources. First is the VEX STEM Library. The VEX STEM Library is an online resources with over 700 useful articles about educational robotics. It provides information to help educators implement VEX in their learning environment. Articles cover a wide variety of topics ranging from targeted step-by-step guides to help teachers set up and use VEX materials, such as how to build a drivetrain for IQ robot or pair a robot with VEXcode, to more complex article on teaching strategies and the research that drives our curriculum. Okay, next one is the educator certification. We offer free online and self-paced training that helps educators at all different ability levels for all our robotics platform. By the end of the VEX Certified Educator Program, you will be fully prepared to implement educational robotics and become a technology and innovation leader within your school and community. The VEX certification style also allows competition volunteers and event partners to demonstrate competency in various aspects of running a competition. Then it's PD Plus. VEX PD Plus is a community learning platform that enables educators to learn from and interact with the experts in classroom and competitive robotics. What's more, it includes the ticket to the annual VEX Educators Conference held at the VEX Robotics World Championship in the US. You will have chance to participate in this exciting networking events.